Welcome to the podcast. Today, we're diving into the world of thorium-based nuclear reactors. You might have heard about them as a potential game changer for how we produce nuclear energy, safer, cleaner, and more sustainable. Let's explore why they're grabbing so much attention. One of the biggest selling points is safety. Thorium itself isn't fissile. It can't start a chain reaction alone. It needs a kickstart from another material like uranium or plutonium. In the reactor, thorium turns into uranium-233, which then fissions to release energy. This gives better control. Many thorium designs, especially molten salt reactors or MSRs, operate at lower pressures than traditional reactors, reducing meltdown risks. Some MSRs even have a cool safety feature. If things get too hot, a frozen salt plug melts, and the fuel drains into a safe tank, stopping the reaction automatically. Plus, the thorium fuel cycle produces way less plutonium and other nasty long-lived elements. The uranium-233 it does make is hard to weaponize due to contamination with another isotope, uranium-232, which emits strong gamma rays. This makes it a tougher target for proliferation. Then there's sustainability. Thorium is estimated to be 3 to 4 times more common in the Earth's crust than uranium. Imagine, known thorium reserves could potentially power the entire planet for centuries, maybe even millennia. Countries like India and China, with big thorium deposits, are keenly interested. Thorium is also super efficient. It can breed more fuel than it uses in some reactor types, meaning a little goes a long way. What about nuclear waste? Thorium reactors shine here too. They generate significantly less long-lived radioactive waste. And the waste they do produce decays to safe levels much faster, think hundreds of years instead of tens of thousands. This seriously reduces the headache of long-term storage. So, where are we with the technology? Progress is happening, especially with those molten salt reactors. They use liquid fuel, which is pretty neat because it allows for continuous reprocessing. Fission products that might slow down the reaction can be removed, and new fuel added, all without shutting the reactor down. China's been making headlines with its experimental thorium MSR in the Gobi Desert, recently refueling it while it was running, a big step. India also has a long-term plan to use its thorium reserves. Of course, it's not all smooth sailing. There are challenges. Building these new types of reactors and the fuel facilities costs a lot upfront, especially when you compare it to well-established uranium tech. Reprocessing thorium fuel, while an advantage in MSRs, has its own technical hurdles, especially with the highly radioactive uranium-233 needing remote handling. Thorium reactors also need a starter material, like enriched uranium or plutonium, to get going, which links them to existing infrastructure, at least initially. We also have less long-term operational experience with these advanced designs compared to traditional reactors. And finally, existing nuclear regulations are mostly for uranium reactors, so new ones will be needed for thorium. Despite these hurdles, the potential benefits, safer operation, better sustainability, less waste, and abundant fuel, keep driving research forward. As we look for cleaner, more secure energy, thorium reactors offer a compelling path to next-generation nuclear power. Continued investment, research, and international collaboration will be key to unlocking thorium's full potential.